Welcome to Mathematics and Statistics. We'll continue with matrices. This is chapter 2 of class 12 commerce part 1 book Maharashtra State Board. Let's continue with exercise 2. So the first question of exercise 1.2 says that you have been given 3 matrices A, B and C. You have to show in the first part, that is A plus B, that is matrix A plus matrix B is equal to the matrix B plus matrix A. This means the order of addition of two matrices gives you the same result. So let's start. So we know that the addition of a matrix is possible or is defined only when the order is same. So first check the order. Here the order of the matrices of all the three matrices is 3 by 2. So the matrix can be added, right? So start with left hand side. Left hand side said you have to add a matrix A with B. So this is your matrix A and this is matrix B. So addition is quite simple. In addition, we add the elements of the respective positions, right? So 2 will get added to -1, -3 will get added to +2, 5 with 2 and -4 with +2, -6 with 0 and 1 will be added to 3. So this is what we get. Now the right hand side. Right hand side says that the order is being changed. So we have B matrix which will be added to A. So this is your B matrix added to A, right? Similarly, the respective elements of the matrices will get added, right? So on addition, we get a matrix which is same as left hand side, right? So these two matrices are equal. This means we'll be defining a property which is a commutative property which says that the order of addition of matrices doesn't matter. The results will be same. This means when a matrix A is added to matrix B is same as adding matrix B to matrix A. Question number 1, second part. It says that we have to prove or show that when we add A plus B and then add this to C matrix, it is same as A adding to B plus C as a matrix. So let's start with left hand side. A plus B plus C. So this means we'll have to add A plus B first. So it is of the brackets first. So we'll go with brackets first. This we have from the previous solution 1, right? And this is C. So addition is possible. Why? Because the matrices are of same order, that is 3 by 2. Right? So matrices are of same order 3 by 2. So adding, we get 5 plus 2, 5, 2, 6, 2, minus 8, 5. Now we'll add B plus C. That's a RHS requirement. So on adding, we get B plus C as 3, 5, 1, 6 and minus 2, 4. So right hand side when added, this means the A, this is A, B plus C is from here. On addition, we get the values which is same as a addition of left hand side. So this proves that the matrices when added, right, irrespective of the order of the matrix, the answers are same or the result is same. So this is the property which is known as associative property. This means when we add a matrix with B and C addition or vice versa, the resultant values or the matrix is same. Going to question number 2, it says that you have two matrices A and B and we have to find a value of a matrix which is given as A minus 2B plus 6I, and I is a unit matrix of order 2, right? I is also known as identity matrix or a unit matrix. So why order is given as 2? Because the addition is defined or possible when the order of matrices are same. So here the order of the matrix is 2 cross 2, right? We can also mention this as I or I2. So let's start. We'll start with subtracting first. So A minus 2B, right? So A minus 2B, so you have a matrix A less 2 times matrix B. So 2B, when we say it is 2B, this means it is also written as K and B. And K here is a scalar quantity. This means it is a common factor. So what we'll do is that this 2 gets multiplied by each element. So we have 1 less 2 ones are 2, 2, right? Minus 2. Each element, so it is minus 2 less 2 3s are 6, that is minus 6. So on solving, we get the value minus 1, 4, minus 3, 70. Now the third part which is left is 6i. Right? We already discussed that I is a unit matrix of order 2 which will be written as 1, 0, 0, 1. So unit matrix says that the diagonal elements will be 1 and non-diagonal elements will be 0. So diagonal elements are 1 and non-diagonal elements are 0. So on solving, what we get? 6i. 6i means 6 multiply 1 which is 6. 6 multiply 0 which is 0. Right? And then it will become 0, 6. So on adding, the value is minus 5, 4, minus 3, 23. Right? Start practicing these sums so that you don't get confused and the clarity of the concepts is achieved. Question number 5 and 6. Why we have taken it together? Because it talks about the transpose of the matrix. So before we proceed, let's clarify the concepts. So transpose of the matrix is denoted by A with a superscript T. Sometimes in some of the books or sometimes in papers, it is also written as A dash. It is obtained by interchanging rows and columns. So the question number 5, order of the matrix is 2 cross 3. So order of the given matrix is 2 rows and 3 columns. So order is 2 by 3. Therefore, when we do the transpose, what happens is that we are interchanging rows and columns. This means 3 becomes my row and 2 becomes my column, right? So what happens? So A of T would become, my rows would become column. So 5, 1 and minus 4 would become the column 5, 1, minus 4. So the row 3, 2, 0 would be my column 2. That is 3, 2, 0. Now the order of the matrix was 3 by 2. And again transposing it, meaning again interchanging. So 3 will become column. The column would become row. Right? So A transpose of transpose is, now this is the given matrix. Right? So the given matrix now is this. Right? So on solving this, we get the column would become row. This is 5, 1, 4 here. And this column will become the second row. This means we have come to the same matrix, that is matrix A, or this is the original or the given matrix, right? So question number 6, again, the order of the matrix given is 3 cross 3, right? So this is a square matrix. So this is 3 cross 3. So order of the matrix would become, when we transpose it, the rows will become column and the column will become rows. So when it is a square matrix, the M and N would remain the same, right? So we'll start 80. So the row, the first row, 731 becomes the column, right? Transpose is very simple. It only says that you are up to obtain by changing the row to the column, right? Now the order of the matrix is 3 cross 3 because it's a square matrix. So when we transpose it again, it will be 3 cross 3. Considering this is now my base and transposing it, we come to the same matrix that was the original matrix, matrix A. Right? So what is the property which we learn from here? We learn that when we transpose a matrix and transpose it again, meaning double transport of the matrix is nothing but the original matrix from where we started. So start with concepts again. What is a symmetric matrix? A symmetric matrix is a square matrix. So you'll have to be very clear. A square matrix is called a symmetric matrix if a matrix denoted by Aij, right? See here, it is a square matrix. So it can be n cross n or m cross n, right? This means the number of rows and number of columns are going to be same. Then if Aij is same as Aji, meaning the row and the column, if are interchangeable and the element values are same, then it is called as a symmetric matrix. So given an example, say this is a matrix, say A, right? So A is given as minus 2, 3 and 3 and 8. So what we'll check first, we'll start with checking the order of a matrix. So it is a square matrix, right? So a symmetric matrix will exist or can be defined. Here A11 is same as A11. This means if I change the row and column, it is the same as the element A11, which is minus 2, right? So A12. So when we are at A12 and when we change the row and the column, it becomes A21. So the elements are the same. This means the value of the element is same, that is 3. And A22, which is same as A22, because after changing we are standing here only, so the element value is 8. Then this matrix is called as a symmetric matrix, right? So if transpose of a matrix is same, meaning if a matrix and its transpose are equal. When we say equal, meaning each element of the matrix A is equal to the respective element of the matrix after transpose, then it is a symmetric matrix. So you'll get these kind of questions in the MCQ or objective types. The null matrix is a symmetric matrix because irrespective of changing any value, the value remains 0, right? So if we keep on changing, we will get the value as 0. So a null matrix is a symmetric matrix. So this can be your objective question for true and false. If a matrix is equal to negative of the transpose matrix, then it is called as a skew symmetric matrix, right? So null matrix is also a skew symmetric matrix because here the negative value will have, right, no impact. So let's go to question number 7. It says that you have to find A, B and C values if it is a symmetric matrix. So what happens in the symmetric matrix? First of all, we'll have to check whether it is a square matrix or not. Here, yes, definitely it is a square matrix because it is 3 cross 3, right? So this is our first check parameter. Now, here it is already given that this is a symmetric matrix. So what will happen in symmetric matrix? We know that first is a square matrix, and after changing the row and a column, right, the value of the element should remain the same. Right? This is what we learned in the previous slide. So here, if it is a symmetric matrix, then we know that A11 will equal to A11. After changing first row, first column, first row, it should be 1. Then A12 would become 2, 1. So which is 3 by 5. Right? So A12 is 3 by 5 and A21 is B. So B value is 3 by 5. A13 will be equal to 3, 1. So what you do is that the row becomes column and the column becomes row, which is A13 is A and this is equal to A31. So where is A31? This is A, third row, first column. This is -4. Similarly, A32. So wherever are we? A32, we have to find this third C. C is the A32 element, which should be equal to, after changing the rows and the column, right? It should be 7. That is 2, 3. So C is -2, 3. When we say 2, 3, this means second row, third column, right? So the answer is A is -4, B is 3 by 5 and C is -7. Ensure that you complete your solution in a proper order. So we start with given facts. Then we need to write what do we have to find. We actually solve the sum and then we write the concluding part, that is the answer. So here, let's start with question number 8. So 8, we have to find x, y, z if a matrix is a skew matrix. So what is a skew matrix? A skew matrix is a matrix which is a negative of the transpose of that matrix, right? So when we say a transpose of the matrix, we interchange the rows and columns, right? And the negative sign makes it a skew symmetric matrix. To find whether it is a symmetric matrix, what should be the basic criteria? The order of the matrix has to be a square matrix. So it is 3 cross 3. So here solving, we get A. This is, say, assuming this is a matrix A. So when we transpose it, what will happen is that my rows will become columns. So this comes here, right? Y0Z becomes the second column. The third row becomes the third column. And since it is given it is a skew matrix, I will have a negative sign here. So we have to find the value of x, y and z. So y, if we see directly, y is nothing but 5i, right? But then this is negative. So minus y is equal to -5i. Therefore, y is equal to 5i. The negative signs will get cancelled. Similarly, z. So this is -z. Don't forget the negative sign. -z will be -√2. So this becomes a positive √2. And x, where is our x? Here. So the x is here. So x is same as 3 by 2. And also don't forget the negative sign. Right? So the x is -3 by 2. So the answer is x is -3 by 2, y is 5i and z is √2. Try solving the 14th question. It says that you have two matrices which are equal. When two matrices are equal, meaning the respective elements are equal. This means 2a plus b will be same as 2, the value, and 3a minus b is equal to 3. Similarly, c plus 2d is 4 and 2c minus d is -1. So how we will be solving this? We have two equations with a and b as a variable and two equations with c and d as the variable. So when we solve them independently, you can solve them independently and get the values of a, b and c, d, right? So you can get a, b from here and C and D from here. So see you in the next part. Keep practicing. Success is possible. May the Master bless us all. Bye-bye. See you.